And there it goes. So hello, and thanks everybody for showing up. Happy Friday the 13th, by the way. So hopefully I'm actually going to be the one doing the focus topic today. So hopefully Friday the 13th doesn't come back to haunt me. Welcome for the call to this installment of our Intelligent Edge Brief call. My name is Kevin Sullivan. I'm a global black belt on the Azure Intelligent Edge team here at Microsoft. And so what that means is I concentrate on a lot of things that are edge or on-prem from a hybrid perspective. And so today, just as usual, especially for those that are maybe new to the call, I'll spend the first few minutes just kind of going over why this call and an overview of what we typically tend to focus on here, as well as just a couple tidbits of news that might be of interest for you that have happened in the last couple of weeks since the last call. Today's focus area is going to be one that I'm going to drive and something that I've been working on as of late from helping with some patterns and some documentation that we're hoping to come out here in the next a month or so officially, and that is focused on AzureStack specifically and specific around any needs and requirements from an AzureStack perspective where we need to have VNet to VNet intercommunication between VNets within an Azure Stack and even in between Azure Stacks, if you will, as well as on-premise. So we'll talk about why that's a big deal, what are the use cases that are typically seen and why people might want to do that and required to do that. And what are the things today and maybe what are the things we're working on to make that a better situation for tomorrow. And of course, anytime Q&A, feel free to post your questions in the chat. Obviously, if I'm talking, and I will be talking the duration of this call, it's going to be hard for me to talk and type at the same time, but I do know that there are at least a few folks from my team, as well as other familiar faces on the line, might be happy to answer those questions as well. And I'll try to leave time at the end to at least log your question if it doesn't get an answer and help you with an answer as best I can. Okay, so again, just the usual disclaimers here. What is this call? It is a 30-minute briefing on everything. Discuss what we or I define really, or we, I guess, as a team define as the intelligent edge and what those offerings are. And I'll talk about how we define that here in a minute. Important to note that this is not a place to share NDA information because we simply can't. I open this call intentionally to everybody on the planet that wants to join. So I don't have any way of seeing if NDAs are there. So therefore, we can't really divulge any of those types of things on this particular call. So just take note of that. Using regular teams. So whether you know it or not, we're all equal partners here. We can unmute, we can steal sharing, we can do all of those crazy things. So far, so good, everybody. The crowd's been manageable here. So no, I do like this for the ease of collaboration, being able to just jump on and off, whether you're internal or external. So we'll keep that for now, unless something else happens. And of course, all the calls are recorded and I post them at that AKS link, which will send you to a YouTube channel that you can subscribe to, as well as just get to the past, I guess, going on 6 or 7 calls we've had so far. All right, so just one thing of news or major news that I want to make sure, and especially for those that may be Azure Stack customers or have Azure Stacks that they manage. And that is, and I mentioned this in the last call, that Azure Stack 19.0 update is available or was coming. 2 weeks ago, I kind of said, hey, this is a big one, and it's a good and awesome one. And in fact, particular to the focus area of this call, I will explain more and more why it's such a good critical update that is coming. Well, it's not coming. It is now available. They had an initial publish, but we pulled it back, and I believe it is now back as far as it was yesterday. And it is a major update. If you're used to the major minor cadence of updates we have, this is a major one. And it also comes with 2 hard requirements. The stack will not let you update to 1908 unless you've done the 2 things, the sub bullets at the bottom, and that's apply a hotfix for the 1907 update. Obviously, that's assuming you're at 1907, so that's obviously a prerequisite as always. But a hotfix after that, And then also working with your OEM, and that link will take you to this OEM version in version 201 or later. So there's links out there if your stack is HPE, or if it's Dell, or if it's Cisco, or it's Lenovo, etc. There are things to do right before we will allow you to push the button on the 1908 update. So keep those in mind, and be sure to reference those links if you haven't already. All right. So just a couple of just high-level things, why we talk about what we talk about. So when we look at edge computing and things that we could talk about from it can include everything from Azure Sphere, maybe HoloLens, what we're doing with IoT devices, all the way up to Azure. What I concentrate on this call is we look at kind of the taxonomy of what we consider what is defined as what Microsoft offers and Microsoft and our partners offer from an intelligent perspective. I tend to focus this call on these two things. So today, AzureStack, which again will be a key focus of this particular call, as a platform in which I can bring a consistent Azure platform down to wherever I need it, whether it's my local data center or whether it's in a field site of some sort, that I need Azure-like cloud platform computing that is consistent with what I've grown to love and use in the public cloud. And that's typically to solve problems of data sovereignty, solve problems of physics, data gravity type things, or a combination of those two. We also have Azure Databox Edge, and a lot of times that is also for the same reasons for AzureStack, but it's a much different from how we implement it and what it is today. And that is, it's a more specific and today containerized compute platform, which we can easily control and manage from Azure, and essentially allow us to bring a lot of powerful compute, a lot of use cases very easily and quickly to, again, perimeter or edge type scenarios or on-premises scenarios. So in these calls, in this series, we tend to gravitate towards one or the other from a focus area, sometimes both, but essentially those are kind of. So let's continue on with the topic of the day. And again, I'm not a very good writer, journalist, author, so my titles tend to essentially be about a paragraph long. So today we're going to talk about AzureStack, and specifically in AzureStack, the things or the options, interconnectivity options we have when it comes to interconnecting virtual VNets or virtual networks within AzureStack or within Azure Stacks, as well as virtual networks to the on-premises network once we have that deployed. So a couple of just kind of high-level overview things for those that may not know, and just to kind of frame this area and this focus conversation. So as we know, if we are competent with Azure and what Azure provides us, among the many things and resources that Azure provides us is this software-defined networking thing. And typically that's referred to as VNets or virtual networks, essentially a way to define typically private IP address ranges, subnets, network interface cards, rules. We call those network security groups, a way to do customized routes, default routes, to essentially allow things that we build in Azure to interconnect and talk to all other things in Azure, maybe to the outside world, but only under specific ways we want it routed and only protocols and ports that we define. We've taken all of that, and in fact, really since the beginning of AzureStack, the network services, or at least what I'll call the foundational aspects of that, have been with the product AzureStack and continue to evolve with it since the beginning. The first AzureStack was deployed in its first build. So in AzureStack today, we absolutely are consistent with VNets or virtual networks. We can define those on our AzureStack environment within our subscriptions and our resource groups, or subnets within those network security groups, rules in those security groups, and you get the picture. Essentially, the basis or the basic aspects or objects that we can find and use in Azure are also things that translate down to AzureStack as well. And again, part of the whole point of Azure Stack being a consistent Azure platform, but on your terms within your physical premises. And so VNets are typically just in general used to isolate, interconnect, maybe virtual machines, maybe app service environments, maybe things that we want to essentially control and basically route the way we want them to, and et cetera. So essentially, virtual networks become the new way of doing what we used to do with traditional VLANs, still do with traditional VLANs and physical infrastructure. So we create subnets. We have I'm getting an echo here. There we go. Thanks, Neelish. So we can essentially define those in the public cloud, because if we couldn't, we would be at the mercy of the provider, that is Microsoft or Azure, to do that. And so we have to basically allow that type of flexibility with Azure, and of course now with Azure Stack within the platform. So now, why is this all important, and what's the big deal? Well, a couple of things to keep in mind. So I said that Azure Stack provides you the consistent networking resource provider elements or things that Azure provides us today. But there are some limitations today that you should be aware of. So there's two things essentially, and again, in Azure, it's the same way. There are two basic interconnectivity, or how is it that if something in Azure and also Azure Stack wants to go and communicate and actually interact with something in the real world, right? So I have an Azure Stack environment, I've got a virtual network. A virtual network may have one or more virtual machines in it. Well, how do those VMs operate and interconnect with everything else? Well, there's two ways. The first way is essentially through an outbound NAT. So this is in a default thing, just like it is in Azure. If you create an Azure VM and then therefore an Azure Stack VM, you have to place it on a virtual network, which you can create at install time if you want, but it has to be placed on a VNet. That VNet essentially will exist within the confines of that Stack environment, and the same thing with Azure environment. By default, if you do nothing else, we allow outbound NAT. So essentially what can happen is you allow that machine outbound, in the case of Azure, to the public internet. It can initiate communication to the outbound internet. You can also optionally create and use what we call a PIP, or a public IP address, which essentially allows that virtual machine to not only outbound communication or initiate communication from itself, but also allow communication in. So essentially you can set up a PIP. Obviously, you probably want to put it behind maybe a firewall, and that's a whole other different story. But essentially, that PIP can also have network security groups to allow only specific communication to certain ports, those types of things. And so in Azure, and for most modern cloud applications, and even the ones that you deploy to Azure Stack, so Kubernetes clusters, or if I'm doing app services, or if I'm doing something that is more cloud native than traditional type of applications and services, a lot of times this is the only thing that's needed. And so it works great. In Azure Stack, we have to define a public IP address pool, which actually doesn't have to be public internet addresses, but essentially that's a whole other story. But essentially, it allows the same consistent functionality and ways in which you can manipulate, maintain, and manage that solution. So it works great. However, there's another mode in which in Azure, and now in Azure Stack, that we can operate and interconnect networks together. And especially when it comes to things that are not so modern, or they're not so cloud native, to where, hey, I just have a couple of exposed public endpoints, and then that allows, essentially for me to expose this cloud service. For example, I maybe just need PIPs. Well, what if I'm in a situation where in Azure or Azure Stack, I want to migrate my traditional virtual machines to Azure Stack VMs or Azure VMs, but I still need interconnection. So essentially, I can't have a NAT in the way. They have to see each other as far as a true line of sight routed network situation. And that is the second way in which we can network things together, and that's through gateways. So again, gateways have existed in Azure for a long time now, for many years. And in Azure Stack, we have gateways as well. And so how this essentially would work is I would build a gateway subnet, same way we do it in Azure, we do it in AzureStack. In that gateway subnet, we would essentially tell the network resource provider in AzureStack, just like we would in Azure, hey, I want a virtual network gateway, and I want you to place it here, and I want you to define all of my subnets that make up my all the networks that make up my virtual network, and then what are the network on the other side of that. And in the case, this graphic kind of shows it in the case of, hey, I want to interconnect my VNet over on the left to maybe my on-premises network on the right, or it could be another AzureStack virtual network, or it could be an Azure virtual network, through firewalls or whatever from that AzureStack up to Azure into another VNet, or it could be another AzureStack. It doesn't really know or care, but essentially the virtual network gateway on the AzureStack side is what defines that. And the graphic also shows this gateway pool, and essentially that is nice because it's part of the fabric, right? I don't have to, essentially worry about architecting as I just ask for a virtual network gateway. Much like it is in Azure, we kind of handle the resiliency and the availability of that VNG, that virtual network gateway you build inside the system. So those are the two ways. Well, here's the limitations, and here are the things that I know I'm getting a lot of feedback from customers, and also this is becoming more and more of a trend of, hey, when I use the virtual network gateway, there are some limitations which may just not fly. I've got requirements that require something better, and here's why. So again, the available options, outbound NAT, got it covered. It's checked, we're fine there. But when it comes to site-to-site VPNs, such as described in that previous slide, and also how I go about, maybe I just have VNets within my Azure Stack, or maybe across Azure Stacks, how do I interconnect them? Well, the problem is on the second set of bullet points, a lot of that stuff's not available today. And at the top, we have limitations with site-to-site VPN connections. In combination of this, we have to find another way. We have to find options. So the big deal with site-to-site VPNs, that they do work. I can plumb, say, my on-premises network to one or more VNets within my Azure Stack environment. The problem is per VNG, I only get 200 megabits per second. That is a hard current maximum throughput limitation of the VNG right now today. Will that be the way it is forever? Absolutely not. But that is where we're at today. So the way around it is use such as the Windows service, such as build VMs with RAS on them, or better, or more supported way is to use third-party NVAs. NVA stands for Network Virtual Appliance, to overcome that current throughput limit. And luckily, there's more than a few to choose from. And so to get rid of these limitations, I can't do peering as it is in Azure. That's on the roadmap. Point-to-site VPN, maybe, but VNet to VNet VPN, as well as overcoming this limitation of 200 megabits, absolutely is something that we can take care of using RAS if we're just kind of playing around and want to evaluate it, or better yet, third-party solution. So what I want to show is kind of a demonstration of this and some of the patterns and guidance that I and some folks on the product group side are working on, that we're hoping to release that might help, especially when it's very easy for me to say, hey, we can do site-to-site VPNs to do VNet to VNet or VNet to on-prem and overcome the 200 megabits limitation, all that stuff. And here's some links to the third party. So what we're trying to do is maybe give you at least a starter, or at least a walkthrough, if you will, to where it's like, okay, no, this is for real. Here is an example. So one of the examples we have here, if hopefully you guys are seeing my slides, my screen share here, in my Azure Stack environment, I have an example I've been working on using the Fortinet FortiGate NVA. Now, Fortinet's not the only one. There's Barracuda, there's Palo Alto. I'm sure there's others that I just can't think of right now, but those are the three that come to mind of choices you have when it comes to setting this up. And so in my environment, I've set up a couple of resource groups just to stimulate and to prove out that, yes, we can do, in this case, VNet to VNet within an Azure Stack using the Fortinet IPsec VPN. And the reason this is important is because if I can prove this out and it all works and it's all good to go, well, that should take care of also the VNet to on-prem scenario, as well as VNet and AzureStack A to VNet and AzureStack B, because essentially they essentially should all work. We just have to make sure we understand where the endpoints are and what they are, and configure each end of those, in this case, FortiGate appliances accordingly. And so in my environment, I've got this now. This is basically showing the resource group that I've built, and I've got a document here. And again, I won't go over it. I just want to show you this is kind of a draft of what I've been working on. I might make this a little nicer. I might GitHub an ARM template or two to maybe automate some of these processes. But for now, I'm just doing the walkthrough kind of the old-fashioned way, using a combination of a FortiGate ARM template that's already there that works great. It does about 90% of the things, and then I'm cleaning up with just some manual things in the portal for the 10% to fix up some routes and stuff to basically make this thing work the way I want it to for this particular case. So in my particular case, I've got this going. You'll notice that I've got a couple of VMs on either side. There's a VNet. I'll just pull up VNet 1. I've got VNet 2 and another resource group. But hopefully you get the picture. I've got the Fortinet gateway 2 NICs in there, defining a gateway subnet and an internal subnet. And I've got a couple of Windows servers on this end, and I've got a couple of Windows servers on the other end. And so to prove this out, let me, hopefully they're still up and running. I've got RDP sessions. Yes, they're still open to a couple. So this guy is at FortiWin 1, and this guy is FortiWin 2. And just to kind of prove there's nothing up my sleeve, it's kind of hard to do this because there really could be, I could be faking all of this, but I've defined a 10.116 network in VNet 1. And let me kill this for a second. And Windows number 2, I've got a 10.2/16. So these guys shouldn't be able to talk to each other, but they can. So if I ping from Win 1 to Win 2, everything works. And the reason is because going back to the FortiGate, I've got a Fortinet FortiGate sitting in VNet 1, and I've got a Fortinet FortiGate sitting in VNet 2, and I've plumbed them together using the IPsec tunnel ability of both of those MVAs. And so the other thing I'll show is, very quickly, an iPerf test. Now, iPerf is essentially, and again, yes, there are things I'm not configuring here. I'm just going to do a very quick and dirty test, if you will, just to make sure I'm getting connectivity, and also just to take a look at what a single TCP session I can get right now at this moment as far as throughput or bandwidth goes. And so as you can see, I'm getting anywhere usually 600-ish, 700-ish megabits per second. So it's proving out that, well, I'm doing VNet to VNet, so that's something I can't do, but I can do through the VP through third party. And also I'm overcoming that hard 200 megabit limitation in the built-in VMG. So you can see this in this particular test around 595. You can experiment with this. That's kind of not fair for a couple reasons. Number one, I should be able to get more throughput, and there's a couple reasons why I'm not. I can do iPerf test to do in parallel, multiple TCP sessions, and then take a look at the aggregate. Typically, you'll see higher than what you're seeing here. That's number one. The other thing too is I did not size, or it's possible that I did not size these VMs, both the FortiGate VMs as well as the VMs that I'm actually running the test from could essentially be running throughput limited NICs on those VMs. So what I mean by that is there is a limit, and this is true of Azure too. So to be consistent with Azure, there are throughput maximums for the NIC or NICs that are in that system. So if you pick too low of a size, that might be the bottleneck. And then the final thing is, and I'm talking to FortiGate about this, which is interesting, is I've set up an IPsec tunnel, and I've used the default highest encryption possible because that's the most secure way to do it. Well, if you're on-prem, or you have complete and absolute control of your facility and your environment, why do I need IPsec? So I'm working with them, and I'm working with product group to also take a look at things like, well, how about instead of an IPsec tunnel, we just do a simple GRE tunnel, we take encryption completely off the table. And that should then make those NVAs less busy, and therefore we should see higher throughputs as a result. We should see a couple gig or so in your average Azure Stack environment between VNet to VNet, and also as well as VNet to on-prem or across Azure Stack, assuming that there's nothing else in the way that's choking, right? That's bottlenecking that traffic. So that's essentially what I'm working on today. This is something that again, you guys have the recording. If anybody's interested in this, maybe even just get a draft. There's nothing here that I wouldn't mind sharing, but essentially, to take a look at, you're more than welcome to it. The other thing I'll point out real quick as a kind of a quick commercial, and I think I had it in my, pull it up real quick. I must have gotten rid of it. Search for it. I also have, if the FortiGate does require activation licenses and stuff, and so you have to kind of contact them to get trials like I did, etc. If you're just looking to prove this out, and this is not technically supported, except for maybe kind of by me, but that means it's really not supported. I have a GitHub repository that does exactly what I'm doing with the FortiGate gateway, but I'm using Windows VMs with RS. So essentially, it proves the point of get interconnectivity via IPsec tunnel. So this is something you could freely download at GitHub right now. Essentially, just cut and paste follow the instructions, cut and paste the JSON, Azure Deploy JSON into your Azure Stack to basically just set this up to at least evaluate and play with it, and how I set this up, what the NSG rules have to be, what the UDRs look like, that type of thing. Okay. All right. Let me go back to here. And with that, and I wasn't monitoring, I don't see any questions on the line here. So I either thoroughly confused everybody, or it was just 100% perfect, or maybe it was somewhere in between. But if there's any questions, let me know. Like I said, I'm happy to help you guys out, and if any of this is useful or a request for more information, happy to field that and help you out best I can. The next call will be 2 weeks from now, which will be on the 27th. And so again, like always, topic to be determined. So check the AKA link for AIEB-topics. And I'll try to post that as soon as I figure out what the topic and speaker will be. But from there, that's all I had. If anybody has any questions, either feel free to unmute yourself or write it in the chat window, and I'll do what I can to take care of you. And thanks, close to 100%. Well, I'm wondering what I missed. Yes, Matt. And by the way, Mr. McSpirit on the chat window is my teammate. He actually, among his many other duties and accomplishments, runs this lab, which he wants to, like yesterday, start the 1908 update process, and I'm the one holding them up because I've got a bunch of VMs on here that I needed for this particular exercise and my documentation. So yes, Matt, I will show you a demo of specifically shutting down VMs quickly.
That's very kind. You don't normally have to shut them down but we're at like 98% capacity. So
98%. I was trying to get to 100.
Well, yes, that would be impossible.
Well, I picked the 4 node, right? So that's why, right?
Thank you. Well, yeah, good say.
Yeah, you're welcome. Okay. Well, if there's nothing else, like I said, I'm going to kill the recording. But if you guys have IMs, you can stay around and I'll follow up with you. If not, we'll see you in 2 weeks. Thank you.